For these ones, we're going to do some algebra of fractions, algebra with fractions in it. It's so important to remember this little rule right here, okay? A over B divided by C over D. One fraction divided by another fraction. A double fraction, if you want to call it that. Kind of like we have here on both of these, right? How do we make any progress with this? Well, it's, if you remember way back, like first of all, this is our main fraction line, okay? So we could write this as A over B divided by C over D. And remember the rule way back from grade school is that when you divide fractions, the way to do that is you multiply by the reciprocal of the second one, right? So you change your divide sign into a multiply, and C over D becomes D over C, right? So it's kind of like AD over BC. That's the formula I want you to know. Let me erase this other stuff here and just write that in, because that's the main thing we're going to have to use here. So it's AD over BC. Okay, so it's like you multiply these two together, that goes on top, and then you multiply these two together, and they go on bottom. So I'm sure you've seen that formula before. And that's how we're going to start off on this first one. Just to save a little bit of time, why don't I just copy this here. And let's see what we get. So like I said, we're going to apply this formula. So it's going to be the top here, x. Well, it's basically, I'm going to leave this as it is. And then I'm going to multiply by the reciprocal of the bottom. So x squared plus 4x plus 3 over x squared. Maybe I should write some... I think I wrote this before, but let me just do it again. It's kind of like A over B. I'm leaving that alone. And then I'm multiplying by the reciprocal of the bottom, right? So right now I just performed this operation. And already it's looking a little bit more, a little less intimidating. I think we need to factor these, okay? The only way to multiply to 2x squared is 2x times x, right? And the only way to multiply to 3 is either 1 times 3 or 3 times 1. Which one is going to work for us? Well, to get to 7x, I need to go, I think I need to put the 3 here, because that gives me 6x. And then 1 times x gives me 1x. So that's the factorization of that. The bottom here is x squared, that stays still. How about factoring this? The only way to multiply to x squared is x times x. And I'd have to have a 3 and a 1 to multiply to 3. And everything's positive here, so they're both positive. Now, what I'm hoping for is, well, actually, why don't we just write this as a single fraction? Multiplying these fractions is easy. We just do top times top and bottom times bottom. For the bottom, I think I'm going to put the x squared out front. And now let's take a look at this. The first thing we probably notice is that we have some canceling we can do. The x plus 3's are common, so they cancel. And this is like x to the 1, right? This x cancels with one of the x's there, so we just have x left in the bottom, as well as the 2x plus 1. And on the top, we just have x plus 1 left over, right? And there's really nothing else we can do there, so this is going to be our final answer. All right. And how about this one? Let's grab it. This one is also a double fraction. It's going to have the extra challenge, though, that on the top, we're going to need to find a common denominator. Because even if when you're doing algebra with fractions, if you're doing adding or subtracting, you still need a common denominator, right? Now, for the first little while, I'm not even going to do anything to the bottom. I'm just going to be recopying it every time, okay? So if I just write that a couple times just to set it up. All the action is going to be happening on the top for the first few steps. I need to get a common denominator here, okay? One way that you can easily get a common denominator when you're subtracting two fractions is you just multiply the two bottoms, right? BD. BD is a common multiple of B and of D. The top then would be A times D minus B times C. That's one way of performing this computation. So if we follow that, it'd be 1 times x minus 1 minus 1 times x all over x times x minus 1. And why don't I put those in brackets? Now let's clean that up. The bottom is fine, but the top can be cleaned up. 1 times anything doesn't even do anything, so this is really just x minus 1. And 1x is just the same as x, so minus x. And I noticed the x's here on the top cancel. Let's see what that implies. Well, we just have basically negative 1 left over then, right? And now I use this little rule of where I'm dividing two fractions, so I leave the top alone, and the one on the bottom gets flipped up to be the reciprocal of what it was before. And I could multiply these, I guess. Or I could even cancel right now. It doesn't matter. So I have x minus 1 on top and x minus 1 on bottom. This minus sign really means a minus 1, right? So we have a minus 1 remaining on the top, and the bottom is just x, right? So there's our answer. Now, is there a way to check our answer? There actually is. If this letter expression is equal to this letter expression, that means no matter what value of x I make up and I put it in here, I should get the same value here, right? Why don't we make up a number x to use? Don't use x equals 0 or 1, because that'll make this undefined. Why don't we just quickly in our back of our minds say x is 2? So then we would get 1/2 minus 1 over 1 over 1 over 1, which is a half minus 1, so we get negative a half, right? And if I put 2 into here, what do I get? I get negative 1 over 2, which is negative 1 over half. So when I put x equals 2 into each of these, I see that I get the same value. And that convinces me that I'm pretty sure I have the right answer. But I just want to emphasize this last part. This was just a check. This is not required. I think it's a good idea to do that, though, just to make sure. Similarly, we can check this answer up here, right? Why don't we let x be a number in here? Let's say x is 1. What would this become? It would be 1 over 2 plus 7 plus 3, 12. And on the bottom, 1 squared is 1. 1 plus 4 plus 3 is 8. So we have 1 over 12 times 8 over 1, which is 8 over 12. Divide top and bottom by 4, so we get 2 over 3. So when I put x equals 1 in here, I get 2 over 3. If this answer down here is correct, it better be true that when I put x equals 1 in here, I should also get 2 over 3. Let's see if that happens. When I put x equals 1 in this expression down here, I get 1 plus 1 on the top, which is 2. On the bottom, I have 1 times 2 plus 1, which is 3. And yeah, I get 2 over 3 as well. So I am convinced that both of these answers are correct. And so it's nice to be able to check your answer. Some questions you cannot check your answer, right? But whenever I can check my answer, I always like to spend the time to do that, just to catch any possible mistake that a person can make. Okay, that completes this one.